second in our three-part series, and it will be actually 4 parts, so this is the second half of the first part, but we will now complete part 1. To begin with, I'm just going to breeze through these 3 pages, so you'll see what's ahead. The line, circle, and sphere we covered thoroughly. The linear systematic space is what science uses. It's the only geometry that's ever been known. And even so-called non-Euclidean geometries are in fact linear geometries. The non-Euclidean in that case generally, I'll just put it this way, generally refers to the non-parallelity aspect. Because Euclid threw in, as I'm sure you're aware, a postulate which for centuries men were trying to figure out just if that could be proved or not, that the parallelity postulate. Then we went on to intrinsic and extrinsic geometries, something I just learned of myself. From all things, the Google chatbot, I forget what they call it, some innocuous name. There's our cat up there. Let's get a quick look. There's the lab cat up on her perch. Well, that's not her most charming prospect, I suppose. The intrinsic geometry is obviously the opposite of extrinsic, but the strange thing about it is that we've never had an intrinsic geometry. Now, if you look that up, and particularly if you start at Wikipedia, you'll find that there is a developed system of geometry, so-called, that claims to be intrinsic. It's not, because it can't parameterize the surface. That's what intrinsic means. You can only have an intrinsic geometry if you have a surface. Nowhere in linear systematic space is there a surface. You might poke a hole in that, but for now, just accept what I say, because we're on the right track, as I'll be showing you. The inversion on the circle was another major insight that I gained early on through a wonderful mathematician named Zvezdelina, which means little star in Bulgarian, her native language. Zvezdelina Stankova. We covered that. The unitization of the eigen, where I introduce a word. You have probably heard of eigen something, eigenaxis or eigenvector. There's even such a thing as eigenspace. There's actually quite a list of eigens, because what it means is a specialized portion of the geometry for whatever reason. The best example, in my opinion, is when a sphere is rotating, it has an eigenaxis, which is the part of the sphere that really doesn't rotate. So it's very interesting, and this comes up in quantum mechanics quite a bit. I'll just say eigenvalues. The reciprocal metricization and two-componency parameterization are probably the longest words we'll ever run into. But then below that you'll see orthogonal harmonization. And where we left off in the last presentation was a recap of what Ali, I won't try to say his last name, but his name is Ali, gave us a very good presentation yesterday. That is, he gave it a while ago, but I commented on it because I thought it was very well done. Electromagnetism according to Maxwell's equations. It's very interesting that everyone knows the right-hand law or right-hand rule. And do you know why you'll hear it hundreds, if not thousands of times if you explore basic geometry, either in quantum mechanics or... The right-hand law refers to chirality, because you can have a clockwise or a counterclockwise rotation. Well, the electromagnetic system consists of two orthogonal forces. That has become I would say, rather confused, because although that is known, that they are orthogonal, I never heard anybody bring out the split that occurs in our mind when we try to understand Maxwell's equations, which have to do with the cross product and something called the dot product, which in some way is the inverse of the cross product, but actually they're orthogonal operators. And he brought this out in a way I've never heard anyone say, or I've never read it in a textbook either. I discovered for myself, what Ali said, but it was very difficult for him to say it. And I know why, but he did anyway and made a very good presentation, which I'll have a link for that if you care, or just watch the previous two, I don't like to say lecture, but presentations. The one before last is the one where I covered and pronounced his name as correctly as I think I can. So parameterization, metricization, and harmonization are three related topics. Harmonization in this case refers to the aspect of the system. And in order to understand what I just said, let me give you the clearest example we have of that. What is the aspect of the linear system? It's called polarity. And technically, it's a 180-degree valence called plus and minus. That is used extensively under a law known as Coulomb's law, whereby we get the concept of charge, which is plus and minus. You've seen diagrams of the atomic system where either one plus or several pluses are placed at the center and the minuses arranged around the plus or pluses. That is incorrect. That is incorrect. The atom is not constructed on that principle at all. Not in any way is it plus minus. Instead, it's the only other relationship that exists in the whole universe besides polarity, according to our level of mathematical and geometric insight. As of the 21st century, things have not really changed since Euclid, in the sense of the characteristic of linear space. It's polaric. That's Polaric. Polaric. Very important word, because I discovered the other form. Now, we already know what it is, but only in linear space. It's called the right angle. That's already a problem. I won't go into that now, but you may be aware that this concept of orthogonality is not something that physicists see very clearly. And I have discovered the reason why that is the case. So harmonization basically refers to orthogonality in spheric space. And that's the pressure system of the sphere. This would be talking about light going out. That's called centrifugal force. So light manifests a centrifugal force. Why? It goes out from an origin. And we're going to be getting into that because that's the quantum paradox, which I have solved, and you're going to see it, what the solution is. I think it's one of the most amazing, surprising things I've ever seen, because it explains so much on just a slight switch of perspective. It has to do with imaginarity, which we are never going to get out of, except I've guided science out of it. So that's my claim. And I'm not asking for money, so there's no real... All right, so that's the end of part one. What we didn't get into, and we will now, is the second half of this page, which ends down at imaginary reciprocity. There's that word, imaginary. So let's start at the top. Frequency and wavelength. You know what that is? It's so simple that it's mind-boggling. The lowest number in the universe is 2, you would have to read all the footnotes and you may raise your hand. You have a question, you have an argument. I understand. I fully understand. I've been wrestling with how to present this for 3 years. So frequency and wavelength, there's only one right way to approach that, is numerically. And then we can derive the geometry. That's backwards. But it can be done. Well, it's done all the time. But it's not the right way typically. You usually start with the geometry. But we don't know the geometry of light. Well, we do much better now. Thanks in part, well, of course, to James Clerk Maxwell. By the way, that Clerk is pronounced Clark, I believe, even though it's an E. I don't know if anybody should or could care about that, but I notice things like that. So frequency is a 2-component number. It's 2/1 is the lowest number in the universe. There's nothing smaller than 2 in action space. You may have heard of the quantum of action. That's the first quantum that was ever discovered, was the quantum of action, and it's called that. You can look it up if you've never heard that term. That is a bona fide scientific term. So the lowest quantum of action is 2/1. It has to be a proportional number, and you'll come to see why in a moment. So then what is the wavelength? Well, of course you know. It's the reciprocal. Well, we just got done with reciprocal metricization of circular space. So what does this mean for us? It means that to the proportion that a frequency being always a whole number, that's what Max Planck discovered. Not only is the lowest frequency 2, every frequency is a whole counting number. That's somewhat redundant. That's been proved. That's the effect of the quantum discovery that Max Planck is responsible for. Yes, he did not like his discovery. If he could be around now, he would like it, because that's one of the most amazing discoveries in the history of mathematics. And the mathematicians have not at all seen it. Only I have. So the relationship between the frequency, which is 2/1, disregard all other numbers, because that's the quantum jump. It's the quantum jump, as we learned last time, from 1, which is a circle, which could be a sphere. The circle and the sphere are virtually identical in our mathematical system and our geometric system and in the universe. And in the universe. This is the right way to start geometry. It's not with Euclid. But there's a footnote, because without Euclid, we wouldn't have any numbers. So that's why Euclid is worshipped. And I use that word loosely to show the intensity of devotion to this outdated Bronze Age number system, which is destroying science right now. And I have the cure, the solution. So wavelength is always 1/2. It always is. Or it's a multiple of 1/2. And the wavelength has a highest wavelength to the proportion that the frequency has a highest frequency. But in this case, if you continue to say highest and lowest, you'll lose your mind. So I'm just warning you, you don't want to say highest and lowest. This has nothing to do with high or low, because that's a linear concept. A linear concept, and there is no direct correlation. So what then is the relationship if it's not polaric? Well, we just discovered what it is. The wavelength is inside the circle because it's less than 1, to the proportion that the frequency is outside the circle because it's greater than 1. And the reciprocal numbers, 1/2 and 2/1, multiply to light speed. And that it is now known that that is the number 1. I discovered that. Physicists do this a lot. They like to unitize certain fundamental constants, such as light speed. In certain calculations, setting light speed to 1 has extraordinarily beneficial effect in your algebra. But that's not what we want. We don't want that. We want the intrinsic geometry of the universe, not the grid. The most that physics will be able to accomplish from now till eternity, without knowing what I know, is they'll simply not be able to get outside the grid. They only are capable of measuring the grid. They can't measure anything that's between two orthogonal lines. It doesn't exist. They try to force it to exist with complexity and hypercomplexity, and also get the numbers back out with the calculus and hypercalculus, and I discovered those two terms. As far as I can tell, I'm the first man to pin down just how fractalizing is mathematics right now. And it's fractalizing every day or week or month or year. It just gets bigger and bigger and bigger because mathematicians are manipulating the numbers to try to penetrate this mystery. It can't be done. You have to switch to two componency number space, or you can't see the relationship between frequency and wavelength. So those are the two lowest numbers, or you could say the two highest numbers. But what you should say to get rid of high and low, that's polaric. We don't want 180-degree valence. Why not? Because frequency is perpendicular to wavelength. It's perpendicular to wavelength. So that proves something very important about the number system we're developing. Instead of being based on a polarity around 0, it's based on semi-polarity, which is called orthogonality, sometimes called perpendicularity. In linear space, it's a hard right angle which kills the geometry. But in physical space, this is a direct match on physics. There's no more interpretation. Once you see that frequency and wavelength are reciprocal, you know that they're orthogonal. But the better way to say it, because numbers cannot be orthogonal, it's a geometric term. Instead, what you say is, they're conjugal. You may have heard of conjugation from your study of the complex number system. I hope that you hate the complex number system. It's a mistake, but it has enormous power to penetrate what linear algebra simply cannot do. So it is a step forward, really practically to the same proportion that the calculus was a step forward. Do you know why these two tools were invented? They were invented for exactly the same reason, to try to give linear numbers the power to compute circular and spherical space. It can't be done. All right. I know you want to object to that, so let me throw in the footnote to save you the trouble of arguing for no reason. Of course, well, I want to keep this brief, so I'm not going to do that. Leave a comment if you want me to explain what I said. It's quite profound. So that's frequency and wavelength. They're conjugal, orthogonal, and reciprocal in circular space. It's identical with spherical space on a very simple transformation. Has been known for millennia. So I think. I'm not sure how much I myself have discovered, because I've never heard anybody talk about this stuff the way I'm talking with you now. Really, to you, since you can't talk back. Well, you can if you leave comments. I will communicate with you. Have no fear to say whatever you want. The rationalization of the metric, what is that? Well, what is a metric? It's what you're measuring. So there's only one thing that the scientific mathematical system can measure. It's linear spatial separation. It cannot deal with time in any way. It only can measure a straight line distance. It can't measure curvature at all. These are the fundamental axiomatic limitations of the linear number system. Remember, it's worshipped. So it will be defended as if it were the golden fucking calf. I have to be prepared for that, but I don't ever want to get emotionally elliptical, like my feelings are hurt, or. So I'm ready. I believe I'm ready. Okay, day 2 of the surreal binary system. This is the discovery of John Horton Conway, one of my teachers. The number system, it's actually a number generator. And the surreal number generator is going to be so powerful for you to understand it that I'm going to give a separate presentation, as I've done in the past. But it's high time I integrated all of this. So we're going to skip that for now. But I do need to at least say something about it so you know why I put it in this list. On day 0, which a mathematician is allowed to do, and he calls these days of creation. Oh, yeah. And nobody's ever questioned that John got it, but he also never got any credit for it. It's totally overlooked. In fact, John overlooked the importance of his number system as well as every other mathematician. Well, I didn't overlook it. So I'm going to briefly explain to you the most incredible discovery perhaps in the 20th century is the definition of a number. Only John Horton Conway accomplished that. Nobody else was able to show what is a number. It's never been done. So John showed what it is, and by doing so, he solved a whole sequence of paradoxes, which is exactly what we need. We need solutions to paradoxes now. Well, that's really hard to come by. Because, well, and we don't want to get off on a tangent, but a paradox is a very strange kind of contradiction, because it's not exactly a contradiction. It has to do with superposition. We're getting there. So day 2, what does that mean? Well, there had to be a day 0 and a day 1. On day 0, John invented the correct generator for a number. It's called a null. It's a double null. And it's based on inequality. And it works. It works. So on day 0 is the split 0. It's just 2 zeros as placeholders. And that solves the problem of why a computer halts on division by 0. Is because the universe doesn't know which 0 you mean. Not even in your binary system, which is 0, 1. So 0, 1 is in the machine logic system. But if you try to divide by 0, you break the Turing machine. It will stop. And that's the end of your computer. You actually have to reboot the system because the system halted and you can't get out of it. It's frozen. It's stopped. Because of division by 0, John Horton Conway accidentally discovered why that's true, and nobody has ever figured out why that's true. So it took John and myself in combination to get the solution to the division by 0 problem. You know what the answer is? There's no such thing as 0. And what we call 0 in the binary number system is not 0. It's something else. And we'll get to that. Now on day 1, the first real number. The first real number after double 0 is double 1. It's double 1. But one of them is negative and the other one is positive. And I just went through very carefully telling you that's the polaric aspect of the linear number system. But it only occurs on day 1. And I'll show you why that's true. It's really amazing. A whole course could be taught on this at university level. Maybe I will. I'd have to be invited, though. I'm just going to walk in and start talking. So on day 1, you get 1. Well, what do you get on day 2? You get exactly what I discovered. is 1 over 2, 2 over 1. They split in two different directions. It has nothing to do with the negative numbers, and that's an important aspect. When the number tree begins at double zero, there's no polarity, there's no relationship, because 0 equals 0. But you need both zeros, essentially to make placeholders for the characteristic of the spaces that will be generated. And that's the null space. Technically, it doesn't exist, but it is a generator. So double null is the source of the linear number system, because from double null, you get +1 and -1 on day 2. Okay? I'm sorry, on day 1. And you disregard the negative numbers. It's a remarkable fact that every line in the universe that represents something physical is not a line. It's not a line, it's a ray, because all distances are positive. The negative numbers are a pure illusion. A pure illusion. They don't actually exist. And we'll come back and I'll prove that to you. There are no negative numbers. So now we have +1. That's the index of linear spatial separation. So that's the first actual number in the universe, is 1. There is no such thing as 0. The universe does not recognize that as a number, but it does recognize 1, and now you know it's the sphere. That's so profound that it's beyond miraculous. So I will be shot at, because this is too much for any mathematician to handle, because it shatters their dream world. Yeah, they worship these numbers. It's like attacking their god. I hope to get around that using diplomacy and pure equilibrium, just logic, just look at it again, let me explain it again. But I still haven't gotten to day 2. What happens then? Well, on the negative side of the split over here, you just lop it off. You don't need it. It's there, but they're called the reflection numbers in linear space. And they have no real meaning. Only the positive numbers do, because the metric of the space is spatial separation on a straight line. There is no negativity there, because you have to have 0, or you can't measure the distance to anything. But what's on the other side of 0? There is no other side. That's the frame of reference. I very rarely hear that. In fact, I've never heard anybody say that. It's the value of 0. It's the necessary number to begin a distance measurement. Without 0, you can't, because you can't get an index, which means you can't get a metric. So that's what +1 is. That's what 1 is. Now it splits again. It also splits on the negative side. It's mirror image on the negative side. But on the positive side, now you have 1, and it splits. I discovered that fact before I knew of John's work. Although I'm not positive about that. I'm going to change. I'm just going to assume that I got that idea from him. But as I recall, I developed this idea. It may not have been perfectly developed in my mind, but I do recall, in fact, now I do recall, is when I was studying John's work, I just saw that on day 2, you get the 2 numbers that parameterize the circle, or the sphere. These 2 numbers are 1 over 2 and 2 over 1. And that's day 2 of creation. What happens after that is of no importance whatsoever yet. I intend to return to that tree and see what happens. By the way, it does not go to 1 over 3. 1 over 3 is part of one of the infinity branches. Because 1 over 3 is a non-representable number. It's irrational. It can't be represented on a computer. All the numbers in circular space are representable. There is no division by zero, and there are no irrational numbers. We'll get to infinity in a moment. So the entire system that I discovered is called the binary numbers. And really a technical difference could be adduced here, and I want to make sure I highlight this. Binary is one way of saying it, but dyadic is better because it refers to the other reflection system. There are two reflectors. One is zero, which reflects polarically. But in spheric space, the numbers reflect spherically. And that's orthogonal in spheric space. I'll show you more about that in a moment. I want to get through this. It is so much to divulge. But this is the number system I discovered. It's been known since the time of the Greeks, but not as a number system. Now this was a later discovery that just came my way when I was considering the extent of spatial infinity. Well, it turns out it can be proved that there's only one infinity in all of mathematics, in all of geometry. There's only one infinity. There are, what's interesting though, and this is kind of the reverse of Cantor, there are derivative infinities, and John Conway discovered that. He really completed the work of Cantor in the exposition of countable and what are called transfinite infinities. If you do it the right way, which I discovered how to do, you find the original infinity, that's spatial spheric infinity. That is the only infinity. So the way to rationalize that, that's not a number, by the way. No matter what anyone says, it's not a number. Why not? First of all, it's imaginary, but that doesn't necessarily mean it's not a number, as I'll be showing you in a moment. What it means is you need another infinity, because that's merely going out. That's the outer infinity. Is there an inner infinity? There would have to be. So let's find it. It's zero. But it's not zero, and I'll show you why. Zero is a Euclidean number, and it only exists on the line. So it cannot exist in circular space or in spherical space. But here's the paradox that'll rip your mind in half. And if it doesn't, you're not thinking clearly. So your only choices are to lose your mind or just be stupid forever. And this is how you lose your mind constructively. It's over the nature of zero. That it is you can see that it's the center of the circle, but it's not the frame of reference of the circle. Instead, the zero is at the center of imaginary space. And what is inside the circle in this reflection is imaginary. And I'll show that to you in a moment. That's called the rationalization of infinity. The correct way to get a number for infinity is to discover it in my number space. And that not only puts closure on John's work, it extends it to the level of super Euclidean axiomatization. I discovered all of these things. So, I'm not trying to pat myself on the back except to the proportion I must now to get review. So this is going into a paper which will be produced before the new year, at least in prototypical form. So the rationalization of infinity leads to the derivation of zero, so now we know what those are, and they are numbers. And I'll show you how that just solves so many problems. So I hope you can see down here. I hope I've had this where you can see it, yes. And now we're going to go on to part 2 and just breeze through this. In part 2, which will be probably tomorrow, because it's nighttime here. We're going to cover the atomic force balance system, which is so profound. I know that you'll want to see that. And to begin that, we're going to talk about the space particle. I could probably indent this. And then we're going to talk about electronic orientation. That does not mean electronics. This is the correct use of the word electron in its adjectival form in describing one of the two particles. Now, it's easy to define the proton as the space particle. No other particle or subparticle or particle piece makes a position. Only the proton does that. The neutron doesn't matter. We'll come back to the neutron because, of course, it does matter. But there's a very interesting aspect to the neutron that, again, nobody seems to have noticed. But the space particle, there's only one. And in that sense, there's only one particle. There's only one particle in the universe. It's the proton, because it makes a position in space. Now, the electron does not do that. How do we know it doesn't do that? Because it's a wave. The proton is not a wave. It's the atom that the Greeks surmised must exist. There are paradoxes attached to whatever you say about the electron and the proton. No matter what you do, you're going to get a paradox. So that's what I mean by electronic orientation. It's not a particle, but if you want to say that it's a particle, the way the particle physicists do, then you have to be very cautious what you say. Because the electron does not have a position. Basically, Heisenberg discovered that. Although that's very... we'll just leave it at that. But instead of having a position, the electron has a locality. Because it has an orientation that can be defined, the electron is said to be a pellet. If it's fired from a gun, it behaves like a particle. It's a quasi-particle, but that's not even the right prefix. It's the antiparticle. But this will rip your mind in half again. So this has to be elaborated, and I just do not want to do it now. If you're curious about any of these strange assertions that I'm making, it's the reason I've made 800 video presentations, is to explain it all. I'm just summing it up right now. So the electron does not have a position, but it does have an orientation in an atom. It forms a sphere. The electron itself forms a sphere. The proton never does that. Although there's another footnote, I made another discovery of the structure inside the proton. All right, so going on to the next item, the spheric, caustic, and evolute. This has to do with the emission of a photon from an electronic shell. And now you know that electronic, I'm using the word the right way. It has nothing to do with circuitry, although in a funny way it does. We'll come back to all this. I'm going to review all this and improve it, but I hope you're enjoying this. I am. We'll talk about the caustic and the evolute. The caustic is the quantum jump, and the evolute is the propagation of the sphere through space. That's the photon. So the photon begins at a spheric caustic. Then that is the quantum. It's actually the quantum jump. And those are two different things. One has to do with action. The other has to do with something else. The imaginary jump. Why would I say that that's imaginary? It has to be. Because in order to make this jump from the caustic to the detached sphere, it has to jump. And this is what made Schrödinger, it elicited from Erwin Schrödinger one of the most interesting statements in quantum mechanical history, because he was encountering this for the first time too from Bohr. And when Schrödinger got the gist of what the hell is going on with this quantum business, he said, "All this jumpity jumpity jump, I wish I never got into this." And it's because it's an imaginary jump which blows the mind of any physicist or mathematician. It blows their mind. I solved that. And then we're going to talk about contraspace. Essentially, I've heard the term counter space. Lori Gardy refers to counter space, and she has a very good handle on it. Really, the only presenting mathematician or physicist I've ever heard refer to counter space. It's not correctly called that in my opinion, but it's really up to the inventor or the discoverer to name it whatever he or she wants. But it's not really counter space because that really doesn't have any meaning. She would probably have a meaning for it. This is not to impugn Lori at all. But I call it contraspace, and that's a much better term. I'll show you why. The contraspace of light speed, or contraspace light speed. Did you know that the photon has a speed? Well, of course you do. It's called light speed, right? That's the speed of light. That makes no sense. That makes no sense whatsoever. Light cannot have just a speed. Why? Because it's not just going through space. Again, we'll return to that when we come back to the collapse of the spheric function. That is the right way of saying the collapse of the wave function. The wave function is already just the term, wave function. It's not a wave. It's a sphere. However, the sphere itself is a wave. So there's no wave function as long as you're looking at the sphere of light. That's called a photon. And it doesn't have a wave function. It has a spheric function. And then we're going to talk about superpositional coordination. By the way, this is always called the collapse of the wave function. That's incorrect. That's why they're so confused. Essentially, it's indicative of their inability, that is, mathematicians and physicists, to see what's really happening. That's the essence of the paradox. So superpositional coordination. I know you've never heard this term before because I invented it. But let me translate this to something you may perhaps understand. How about entanglement? I will explain to you why entanglement works. It does violate special relativity. It violates every form of relativity. And it's not because relativity is incorrect or disproved. It's because relativity is a superpositional concept. And again, I'll explain that later. I try to breeze through this. Now we turn to the second part of part 2. This is really 6 parts, okay? 3 sections in 2 parts each. Macrospace. What do I mean? The universe. The real universe. Not the imaginary universes of the cosmologists. The actual universe. That's called macrospace because it's at a different scale than local space. All it means is that it's bigger. Well, maybe you've heard of a singularity. Well, have you ever heard of macrospace singularism? That's because I made up the term to describe the actual situation. We're going to talk about the quasar. Something you probably have heard of, but do you know anything about it? I'll tell you this. There are about 1 million artists' renditions of the quasar. Because the quasar is a black hole, but it's not in the same state as a black hole. Obviously, it's in the opposite state. Because the quasar is by far the brightest object in the universe. There is no star that can compete with a quasar. Because the star is at a certain scale beyond which it cannot get. But the quasar is at galaxy scale. That unites the concept of the quasar with the galaxy. I discovered that. Nobody knows that. It's easily proved, though. And then we're going to tune the Hubble tuning fork. This is also worshipped for fairly good reason. I don't mean this disparagingly. I'm provoking the necessary level of intensity that science relies on these things. So, what do I mean by tuning the Hubble fork? As you know, or you should know, Edwin Hubble created a tuning fork model to describe the difference between the spiral galaxy system and the elliptical galaxy system. For elliptical, you could scratch that word out and put in spheric. There are two kinds of galaxies, roughly speaking. Only it's very important because it describes all galaxies. Whatever anomalies or exceptions may be noticed, and nature is funny that way, but keeping things simple, there are only two types of galaxies. There's the spiral, and there's the spherical. Do you know why? None of your astrophysicists do. They're completely gone with some model they invented whereby everything is due to accretion. And that's why all the millions of artists' renditions of the quasar, or the active galactic nucleus, or a supermassive black hole, they are all simply incorrect, because it shows the model of accretion, which I disproved. And that will change astrophysics forever. Assuming there's no resistance. We're coming to a discussion of that, but not now. And the last aspect I've put off by itself, dark matter. Dark matter is a major thorn in the ass of real science. Dark matter was actually invented, the term was invented by one of my teachers. And I've never been able to fully explain to myself, from having read practically all of Fritz Zwicky's work. I read his book on astrophysics twice and took copious notes on it. That was burned up in the campfire along with everything else. But Zwicky noticed in the Coma cluster of galaxies that it's impossible to explain its cohesion with standard gravity. And so what Zwicky actually discovered was another force at work at macroscale besides gravity. I know what that is. It's easily proved, but there's no such thing as dark matter. That is very important. So we're going to get into that. Then we're going to talk about hyperspheric rotation, which will explain a lot. And then in part 3, we're going to talk about cosmic morphology, and I'll teach you what that word morphology means. Then we're going to talk about continuity, and this introduces the Bošković system. So we're going to talk about how Bošković solved the equation for the atom before the atom was discovered. He got the exact solution almost, and it was completely overlooked. Guess why? It's because of this guy, Newton. Nothing against Newton. This is just the way science goes. Newton was far more exciting than Bošković. Well, that's too bad, because Bošković got the right answer and Newton got the wrong answer. And we're going to talk about orthogonal infinities. I discovered that from looking at the Bošković force curve. And then we're going to talk about concentric force fields, which will give the first ever insight into the dynamic system of the universe. And then we're going to talk about the anomalous magnetic moment and the fine structure constant. Those are exactly the same thing. The anomalous magnetic moment and the fine structure constant are the same number, except for a factor. Can you guess what the factor is that makes the fine structure constant equal to the anomalous magnetic moment? It's tau. Then we're going to talk about Planck units, which are extremely tiny, and huge largeness. Paul Dirac spent the last decade of his life studying huge, large numbers. And he died frustrated. I will show you that Dirac was on the right path when he died. It's just too bad that he couldn't get the answer because he was saddled, as was Einstein, with a hideous Bronze Age number system. I've solved all of that. And then we're going to talk about the curve of quantum infinity. This will take us into the heart of the atom and the heart of the proton, and we're going to learn everything we need to know that solves all the problems in physics, all of them. And then we're going to talk about how to proceed. The role of the calculus. It's very important to disembowel this hideous monster called calculus. It's a version of sickness, and anybody who's tried to learn the calculus knows what I'm talking about. And then we're going to talk about the role of complexity. That is the complex number plane or the complex number system. It's really neither one. What it is a kludge, a kludge. That means a mistake. And complexity does not work. And then we're going to talk about the human equation. Because in the last phase of science is to use the knowledge that you gained in order to answer human questions. This will come down to you, and only you will be able to get value out of what you learn. However, there is a philosophical side having to do with humanity in general. And I have the angle on that that's going to blow your socks off, or you're not a scientist. You must understand, this gets megalomaniac at this stage. I live alone, and I've known about these secrets, which basically I discover something new every month that changes science forever. Well, that doesn't happen very often. So I hope you enjoyed this. I hope you understand that I'm under a lot of emotional, I won't say duress, I actually feel very calm. But I wish that I could present what I know without being emotionally elliptical. I wish I could talk like Spock, Captain. I'm human, okay? And that actually is both a problem and a blessing, as I'm sure you probably could credit. So keep looking up, stay tuned, we're going to have more tomorrow. It should be pretty easy sailing. I gave you all the difficult stuff at first. Because in induction, which this is, the hardest step is the first. And it's upside down from computational difficulty, where the difficult part comes at the end. But in induction, it's you turn the pyramid over. All the difficulty comes in getting the right orientation and framework and axiomatic basis, which could take more power than your brain has. Well, I was blessed with these insights, and so I'm hoping to share them because I took a vow to do so before I knew I was going to discover this. All right, thank you very much for tuning in. It really means a lot to me. And we'll be back. Keep looking up.